Welcome to Ask and Learn.
This is the answer to Chapter 21, problem number 31 from the Smith Organic Chemistry textbook. This problem asks us to draw a stepwise mechanism for the conversion of this ketone into the cyclic acetal. And so this is a fairly lengthy mechanism, so I'm just going to jump right into it. So the first step is going to be protonation of the ketone by the tosic acid. And so we now have the protonated ketone. So we'll have one lone pair and a positive charge on that oxygen. And in order to relieve that positive charge, one of the two double bonds is going to break. And so really this is just a resonance structure that we're drawing here. And so we have this resonance structure where we have an alcohol here now and two lone pairs on the oxygen and a positive charge on the carbon that the oxygen is attached to. So the positive charge is on that carbon now. Okay, and so that is where one of the alcohols in ethylene glycol is going to attack. So one of the alcohols can act as a nucleophile and attack that positive charge. And so when that happens, we get to this intermediate. Let me redraw that a little better and a little higher up. A little better. Okay, and so we get to this intermediate. So we still have our alcohol here. And now we have the ethylene glycol that's added here. And there's still a hydrogen on this oxygen. So this oxygen has one lone pair and a positive charge. And so in order to get to the hemiacetal intermediate, the last thing that we need is for the tosic acid's conjugate base that we formed in the first step to come along and grab this proton. And so now we have our hemiacetal intermediate. Okay, so we formed our hemiacetal. And so essentially, we need something very similar to just happen again here. So the first step from the hemiacetal is going to be protonation of the alcohol, again by tosic acid. So we have our protonated alcohol here now. It is going to leave. So it has just one lone pair and a positive charge. And so it is going to take off as a water molecule. And so now we're back to having a carbocation, ideally situated for attack by the other alcohol on the ethylene glycol. Let me erase this and draw it better. Okay, so we have our positive charge seated here again. And this is going to allow for this other alcohol to come in and attack. And so now we are here. There's still a hydrogen here. And so, of course, this needs to be deprotonated. And again, we can call on the conjugate base of the tosic acid that we formed a couple steps ago. To come and grab that hydrogen. These electrons will revert to the oxygen. And so there we go. That's the formation of our acetal. So after that deprotonation, we have our acetal product. So there it is. Okay, so kind of a lengthy mechanism, but it's really just protonation of the carbonyl and then attack by one of the alcohols in the ethylene glycol, and then deprotonation to get to the hemiacetal intermediate. And then the alcohol of the hemiacetal is protonated. It leaves, and then that carbocation that forms is attacked by the appended alcohol. And that forms our acetal, which then just has to be deprotonated to get us to our actual acetal product. And that's the answer to chapter 21, problem number 31.